Beating the Waiting List Backlog. My name is Tony Stakeover, and I'm a medical doctor and Director of Innovations at Cambridge Medical Academy. Today we will present to you two projects which we have been working on. Both are newly completed, Track and Know and Backlog. And I would like to thank our audience for joining us today. We're hoping for a very interactive session. At the end, we will be discussing some questions. Now I'd like to move to the Backlog project. It is a lot shorter and smaller. It's lasted 6 months, but it is a nice addition to the Track and Know concept, to the requirements, and it's just happened to be in the right time there. Those results from Track and Know that allowed us to propose more tools, because the COVID crisis basically hit the waiting list really bad in the UK and probably also worldwide. And there were new approaches required, because you can no longer use some of the existing clinics. You have to look for new clinics. You have to work with geolocation and IT in order to work out how can you clear out those waiting lists. There has been an NHS request to improve the allocation and find new facilities, and so therefore Backlog has suggested some additional key techniques to help the service managers to simulate. We've also got now here two different medical pilots. One medical pilot remains the obstructive sleep apnea, and we're building on what we've done before. In that service, now we've also been looking, other than changing clinic positions, we've also been looking at how can we include now third-party options. We've also been helping them to calculate what it would take if you would visit the patients or deliver tools to the oximeter to the patients as opposed to seeing them in clinic. So we've worked out different scenarios. Whereas the second pilot is the lung function service. That has a problem that patients, due to various constraints, can no longer attend normal clinic rooms at Papworth, or they attend them at a much lower number, so therefore the list is increasing. However, this service can be delivered via a traveling staff member going to the homes of the patients, and we're helping the service calculate how many they can see per day and where are the clusters. So this is on our website. It's just different main tools, but there are also other sub-tools that allow us to do the analytics. Where is this information stored? Now we are very proud that we managed to contract as a provider for the cloud server. That is very highly reputable in the United Kingdom. This is UK Cloud, and as you can see, they are providing the storage for very solid places like the Home Office and Cabinet Office, Ministry of Justice. So we thought our NHS data are very well placed there for the simulation in and out. Who is the Backlog user? The Backlog user is again the service manager who wants to have different options to allocate resource for clearing the waiting list. But here is also booking staff could take direct use of the same tools, because they can directly produce at the end of the day an allocation list of patients where they could go to. Now, before we run the demo, I'm just going to show you a couple of shots of the interface. So the user goes in here, he's welcomed, then he selects the tasks, he can put in his data, selects the task that he wants to do, and so some of the main, I've got a few screenshots that Athanasius will show you the actual demo. So some of the main outputs that we look at, one is you have this waiting list. The waiting list is already being prioritized by you, let's say, physician who receives the referrals, and after the patients have received their priorities in the referral system, then this whole list can come to Backlog, and Backlog works through the list and tells you, on your list you've got patients, X number of patients in this priority, you know, it is by urgency. They've been waiting for such an amount of time, average wait, so you can actually see the distribution And it's important because you know that you want to allocate one priority more urgent than other one. So then there is a view on the map where the patients are not only, the map allows you then to see the geographical clusters. Where do you have patients across the area? And you would see here, for example, how many patients there are in a cluster. And then you're also able to see where, for example, in this example, pharmacies are as potential third-party providers that you could use. Then you can drill down and you can see within this cluster what is the nearest facility that could be possibly used to serve those patients. So I've given you a very brief idea of what you see. Thanasis will show you a bit more. The last slide I want to show you is the heat map. So if for a priority you select, let's say for priority 1, you can also see a density map or heat map where most of your patients are located. So now we're moving over to Thanasis. I have to unshare my screen.
This is the interface. It's a web application. The user logins with his credentials. The credentials are created when you create a new user, and once you create a new user, the user verifies his email, and then he's able to access the platform. Then the user has a file with all his patients. So what he does is select the files, set some settings, and then starts the processing of the file. For the demo purposes, I'm going to display a ready-made file updated and processed already. So when the user decides that he wants to explore a specific file, at first he sees a visualization of the data. We have the priorities in charts. Per priority, the column is the number of patients, and on the curve we can see the average waiting time per priority. This is an average value, meaning that most of the people are around 130. There could be somebody that's been waiting for a less time or more time, but this is an average value. The user has the ability to click one of the priority that he decides, so he can focus on one priority. We can zoom in and say we decide to select priority number 9. So we can see on the main map only the people that are related to the priority 9. The platform also has a variety of nearby areas. I'm going to remove all of them just to deobfuscate the UI. Zooming in, we can see the clusters of patients per geographical area now for the selected priority 9. And we can decide to display hospitals, pharmacies. Pharmacies obviously are a lot, GPs also a quite deal of number, and some main stores. Moving forward, we have the capability to cluster the selected results. This normally takes time, but for demo purposes, the data are already clustered. So we have two visualizations. For a selected priority, we see a heat map and the number of total patients, new ones, and the follow-ups. As we see, for Papworth, most of the patients are in priority 1, are the new ones, and the rest of the patients are follow-ups. And moving along, we can see by sliding the slider, for most of the patients are in priority 5, and especially in the area of Cambridge and Peterborough. Moving further down the line, we have another visualization tool. Since we have a lot of clusters, it's not really easy to use any tool in order to classify them and display them to the user-friendly. So we're taking the average priorities, and we can see obviously that the bigger priority is number 5. If we click on this, then we see the actual clusters under this priority, and the size of each cluster is actually the size of each patient, the number of patients. Moving on, we can run simulations. One important simulation is the estimation of the optimal facilities. We select for this demo time. This is the factor that the decision of criticality is time and not distance. So the facilities will be placed based on less time travel than the distance. We're not going to include patients that are out of bounds. Out of bounds is patients outside of this UI. We set a minimum value of, for demo purpose 3 and 5, and then we run the p-median. This also takes time, more than a few minutes. So what we can see for 3 facilities, 2 facilities are suggested to solve all the backlog. 3 or 4, and since we are raising the facilities, we reduce the travel time. If we focus, for example, this area, we can see that the red one is the second location of the 4 total locations that are suggested in order. Instead of 1, 4 are suggested here as optimal placements for clearing the backlog. Around it, we have identified POIs, a supermarket, a pharmacy, and a hospital as an alternative positions for instead of building a hospital or renting some space, to use these facilities instead of the main suggested facility. The last, and also quite important, is an estimation of what happens for a doctor that he's traveling to the patients. We estimate a duration visit of 5 minutes. There's a 5 minutes before and after procedure duration. For example, cleaning, especially now with the COVID, doctors take more time in order to prepare, change clothes, and so on. In total, we estimate 8 hours of work. As a starting point, we enter the postcode, since address is much more detailed, as postcode is much more relevant as a starting and an ending point. Now I'm putting here a random, which is not really used, and the total number of physician 1. Taking account into this data, we run a simulation, and we expect to see what is the distance that the doctor will need to travel for these settings and for the specific cluster that we have identified, and how many patients he can see per day. Following, we have a rough representation of a pre-selected group of patients, and what is an average route that the doctor needs to follow in order to go and see all the patients for a single day. So this pretty much is the UI. It's a top to bottom graphic in order to guide the user from a lot of information going to detailed information as where to place a facility or where the doctor should travel.
Okay, so just to explain maybe why this is important. As we know, we have a problem with our core facilities that we have been using. The push to move to alternative facilities has been very, very high and is much needed. So apart from identifying private hospitals that could take the services, or GPs, or even pharmacies, there is this opportunity to provide mobile services, and that's why those supermarkets are important. So we're not actually going to the supermarket, but the large car parks that could be used to deploy mobile services, for example, for x-rays for patients, or for various other, even for pacemaker checks. So there are many services, not only the respiratory service that I showed you as example, that have things that can be done outside, consultations that can be done outside. And it's about deciding how fast can you do it if you do it outside, how many patients do you see at the moment in your clinic in Papworth, and then what would happen if you could tackle this cluster of 60 patients, and how fast can you clear those? And that's where you need the supermarkets as alternative facilities because of the parkings, the pharmacies, the GP surgeries, and possibly also other locations. So we hope that you have gotten the main idea of why we started looking at those alternative options. Now, let me just move my slide. Okay, so maybe translating what we're trying to do is to try to get the right patient to the right place at the right time at the right resource. So we're trying to help the NHS help save resource, but in order to save resource, you have to know where can you position your mobile resource and how fast can you clear waiting lists this way, because the system shows you how many patients can you see in this area of that priority on a day. So this is our contribution to the business intelligence for demand and supply. In addition, also those modules that we have developed, they are easily integratable in various different environments. They can interface with the NHS workflows. You can scale them up, you can add on additional tools. But you can also use them for other services. It doesn't only have to be health service. For example, the social health and social care. In social care, there is so much demand. There's such demand for certain visits, home visits. Here are patients waiting, not being seen. You can plan a lot better if you would help the other services with your innovation as well. So we do feel it's very much transferable beyond what the NHS only needs. How can you estimate the value? You can estimate it obviously from one side, looking at the health outcomes by preventing unnecessary complications, seeing the patients as fast as needed, preventing admissions, so that's the health savings, but then also the cost savings, because you don't want to waste resource, you don't want to waste waiting time, being stuck in the main hospital. You want to find other more cost-effective solutions to see more patients with the same staff, or calculate if you need more staff or mobile van, what would be your benefit if you invested in more staff in a van, for example, a medical van, what would be your cost benefit to see also more patients. So this is just a summary of what we have tried to innovate about. So we were looking at designing innovative tools that will hopefully help you and also hopefully help innovate in the service and make it more effective and make it more resilient to the crisis, because you have more options. We want to give you more intelligence in order to know make decisions how to manage the crisis. So we are trying to innovate the service and the organizational models. So thank you very much for listening to the presentation and the demos. In conclusion, I'd like to raise a few questions that we would like to discuss today with you, but also invite any other questions that you might have. So clearly we want to know, based on the short presentation and the overview, do you feel that your hospital or service and your patients would benefit from the use of such tools? Which functionalities would be most useful specifically for your service? Also, who's the decision maker to say, yes, I'd like to have this kind of intelligence? Because I mean, obviously we need to know who we should be talking to in order to help you for your work, but also what barriers do you see? What concerns would you have in using such tools? Maybe you have some suggestions for additional functionalities. We'll be very happy to help. And overall, if you have also any data that you would like us to put through the system, we're more than happy to help you and show you how this works with your own data, obviously after anonymization and proper data management before being released. So that's my presentation for today. I'm just wondering if Dr. Ian Smith would like to make a short comment before we open the floor for discussion. Ian?
Yeah, so thanks for that. I think it's really interesting to see the way that the modelling is coming out. We've already learned quite a lot by looking at our existing data. I think one of the things that was we sort of knew about, but hadn't really been able to focus on, was the very high DNA rate and how that's been growing. And so that gives us the opportunity to look at some hypotheses as to why that should be. And I think part of it is going to be because a lot of our patients are follow-up patients who've been coming to our service for 15, 20 years, and they're getting older and they're less mobile. And so again, the way that we interact with them has got to be remodeled, because we have to take that into account. I think, I think that there's huge potential for this, because the way the system works at the moment is very much down to a clerk just trying to do their best to say, how do we provide the right appointment, right place for people, and with very little backup of how you could group those together. But I think potentially we would see this system running in parallel with what the booking team were doing, so that it would give suggestions of here's a group of patients, maybe you should put them all together in one day, and we would go out to them rather than ask them coming to see us.